Okay, so you need to get your books out and take some notes. I'll give you some handouts as well. Okay, so guys, is there any reason why you have to sit at the back each time? Okay, so when we attack when we create a software program, we actually call it a software solution. Okay? So throughout the course, if you hear about the solution, we're talking about creating a program. It's called a solution because we say that the program is solving a problem. Okay? So in our course, there's 5 approaches. Five approaches that are used to solve the problem. 5 approaches to produce a solution. Can you take out your book and take notes, please? Or your laptop or whatever device that you use to take notes. Does anybody know any approaches that we might use in software? No one's read any of the textbook? You're taking your notes on your phone. Is that right? Well, you didn't read my book today. Okay, guys, you have to bring your books. Alright? Okay, we'll be doing more theory now than we will be hands-on. Alright? Giving you a lot of time to do your exercises. Okay, so it's a category A course. Your exam next year is 3 hours. Yes, and hope you're not chewing up, mate. Okay, it's no use rolling up here, guys. We just want to play around, or you don't want to take any notes. As I said, HSC exam is 3 hours of theory. It's a 3-hour theory exam. Okay, there's no keyboard. Alright, so you've got to know your theory stuff. Do you have a pen? Well, mate, this should be already written. Okay, so don't go, yeah, as if it's obvious you do, because it's not out. So nobody knows any approaches. Okay, so one of the approaches we use is called end user. Another one is RAD, which stands for Rapid Application Development. Another one is called prototyping. We have the structured approach. We have agile. Has anybody heard of any of those? Cole, you don't have a book?
Oh, I've got to bring one.
Come on, you check your timetables the night before, you pack your bag accordingly, guys. Okay, so has anybody heard anything about any of those approaches? No? Does anyone have a guess what any of them might be? Or what they might involve?
Is end user like terms and conditions sort of?
That's a good answer. As in like end user license agreement. It's not, because we're actually looking at the approach, the approach that we take, the way we're going to solve a problem, the way we're going to create a software solution. Yeah? We're looking at how we're going to actually write some software. That was a good guess. Anyone else want to have a guess what something might involve? Yeah?
It's structured kind of like writing some of the code out and developing the base structure for the code and then putting it all in.
It does involve writing the code, but all of them would involve writing some code. But the structured is the most time-consuming and most cost-consuming. Time is money, as the old saying is. So if something takes a lot of time, it's obvious it's going to take a lot of money. Because if you're paying people, or if you're working, for somebody, you're taking a long time to do something, it's going to cost more money. If a guy comes to quote you for a job at home, if it's only going to take him an hour to dig the hole, we'll quote you $100. If it's going to take you 3 days to do it, it's going to quote you about $3 grand. Okay? So things that take longer are going to cost more. And our structured approach is more involved because it's thorough, it's formal, costly, time and money. With the structured approach, there's 5 stages of the cycle. And later on in this lesson, I'll give you those 5 stages. Structured approach is what is usually used with software companies. It has been used up till a few years ago. Okay, the end user is probably the easiest. I shouldn't say easiest. It's the least formal. Okay, the end user is where the person that writes the code is probably the person that's going to use the code. Now remember the other day I asked you guys to write a budget in your Excel? Okay, that's the end user approach. You don't have to do a lot of paperwork for it, you don't have to do diagrams for it, you don't have to interview somebody for it. It's not going to cost a lot of money because it's for you, or it's for mum, or it's for your brother, or for your dad. Okay, it's not someone who's been, well, it might just be for a mate to play a game, something like that. You're not trying to make money from it, you're not putting it out there, it's not being marketing, you don't have a client that you've got to speak to. The end user is you. You're writing it for yourself or for someone with you. Does that make sense? So it might just be a little Excel program, it might just be a small Pascal program, it might be something that calculates pocket money, it might be something that calculates how much you got for your job, how many hours you need to put into your set of subjects. You might write something that calculates your marks and weight against other subjects. So the end user, the programmer, is the user. And so you write it for yourself. So I do a lot of this stuff because in my job I do a lot of repetitive stuff, do a lot of data, 650 students. So I write small programs for myself that cuts down on my time. It might be something simple like stripping commas out of a text file. When I put you guys in the board of studies, I have to put every single person in. I used to have to do that individually, so sit there and put one person at a time. Now I've automated, so I've written some stuff that makes it so I can bring the whole year group in, and I can bring all your subjects in one big code rather than sitting there ticking. I used to have to go, Nathan, English studies, Maths General 1, do Tech Life Skills, 3 more subjects saved, and go on to the next student, put their address in, say whether they were female or not. 350 students in year 11, and one after the other. So I've written stuff now that makes it a lot easier for me to use. So I've used the end user. I haven't gone out and interviewed a client. I haven't said, okay, tell me what you need, what's your problem, let me talk to your staff, show me your system, okay, here's some diagrams saying what you've got. So it didn't take me a long time to do it, it didn't cost me a lot of money. Okay. A lot of people get confused with this one, rapid application development. Because it's a big long name, they get confused what it is. Rapid application development is where software developers take a program that's already been written, such as Excel or Microsoft Access, they take a program that's already written and then they put a different wrapper on it. You want to write that down, Jess? You want to write that down? So rapid application development is where the programmer uses a program already written. come and sign in, that program is called Academy. However, the back end of it is actually written in Microsoft Access. Okay? Access is a database. You've probably got it on your laptop. Have you listened? Got Microsoft Access?
Yep.
You got Office on there? If you've got Office, if you've got the full suite of Office, you've got Access. It's written in Visual Basic. Okay? That whole suite is all one big thing of Visual Basic. Your Excel, your Word, your Microsoft Access, all written in Visual Basic. Okay? That's why they get to interact with each other. You can throw an Excel document straight into a Word document. Okay? So, rapid application development. Rapid means fast. Okay? So it's quick because you don't have to sit there and write the code out. You don't have to write all the source code. The code's already written for you. You just have to understand how to manipulate it, how to manipulate the elements of that program. So when you guys come and swipe in, or if you're naughty and you get something put against your entry, or if you do really well and you get a commendation letter, there's a database. There's a database for each student, okay, and there's all these fields that keeps all the information about you. So it's actually Microsoft Access, although when you start it up, it doesn't look anything like Microsoft Access, because these guys called Academy, they've got their own company, Academy, they've taken that and they've put their own wrapper on it. They've made it look like their own product. Does that make sense? Okay, so it's faster for them to do that rather than going back and writing a great big hunk of code. All right. Prototyping. Prototyping is where anyone might want to have a guess at what the prototyping might mean. Yeah, Louis?
You have like a test, like an unfinished build that you send someone
Yep.
for testing.
Yep. Okay. So it's where we come up with models. Okay. Now we have a lot of feedback with the client. So the prototyping is where we involve the client. Involve the client, a lot of feedback, but we continually show the client the product. So the client can go, yeah, I really like that. No, I don't like that. Oh, wow, that looks terrible the way you've got that. Wow, that's really good. Okay, but yeah, hang on. When you did that, I actually wanted to do this for you. Oh, okay. And there's two different types of prototyping. There's throwaway and there's evolutionary. Anybody want to have a guess what the two might mean or what the differences might be? With cars, they do prototyping. Okay? They come up with a car, they build a prototype, they get a couple of people to test drive it, they give back their feedback, go, oh, the handling's great, but the suspension's terrible, the fuel efficiency's fantastic, the stereo's crap. Okay? They give their feedback. Now, evolutionary is where they keep on going back, they get the feedback, they take it back, they tweak it up, they go back again and say to the client, now what do you think of it? A few more recommendations, take it back, tweak it up again, they keep on doing this, and when they're finished with it, they go, well, we think we've got what you want. The throwaway is where they go, okay, we've got all your feedback, we're not keeping the one that we worked on, that was just a prototype, we're throwing that away, and we're starting from scratch, but keeping all your recommendations in mind. Everyone's seen the Simpsons episode where Homer meets his long-lost brother, Herb. Herb runs a car company, car manufacturing company. Homer designs one, and the car makes him go broke. Well, when they first, I think they called the car the Homer, didn't they? It was terrible. Well, that car was a prototype. The thing is, they started building it all based on the prototype before people got their feedback. Okay, so that's what they do. Because they mass build cars, they build a prototype first. So they don't start making a million Yaris's and then throw them out there and go, they're shit. Like, well, we don't like them, no one's going to buy them. They have prototypes first of people try these cars and go, yeah, okay. So with a prototype computer program, you keep on getting the client involved. But it's not actually the work, it's like a model. Okay? Like model trains, it's not a real train, it looks like a train, it moves like a train, but it's not a real train. Okay? So what you're showing then might just be simply a PowerPoint. and the buttons that you've got on there might just jump to different pages which simulate an action if you press a button. Okay, because you don't want to do all the work here. You don't want to write all the code and show them they go, that's not what we wanted. Okay, now the structured approach is a lot more formal, as I said, and the Agile's only come around in the last few years. Okay, and it works, it's small teams, involves the client. It gets it out in the market quickly. And therefore, if it gets it out in the market quickly, what do you think that might imply? Gets it out in the market quickly, so what do you think could be the implications with that? Exactly right. But so with the structured approach, there shouldn't be many bugs in it at all. Okay, but with the Agile, it's accepted that there's bugs in it, but the thing is they want to get it out on the market quickly, so they've got a presence. Okay, and they're happy to have bugs, and they'll get feedback from people using it, and they'll fix the bugs as they go along. Okay, gets out in the market quickly. The reason it gets out in the market quickly is why?
They don't spend time using it.
Okay, what's a market? What type of stuff do you think the Agile might be dealing with, and why do you think the Agile's only come around in the last few years?
Smaller companies trying to expand.
Yeah, okay. It's only been the syllabus for the last 3 or 4 years. What's been the big boom in the last, say, 4 years, 5 years? Technology. Yeah, in what? In software. Talk about software. What type of software has been a really big boom in the last few years? Internet shopping. Is that a program? What do you guys use? What's he using right now? Right. How has software changed in the last few years, do you think?
Better phones.
What? Sorry?
Better phones.
Better phones. What's on your phone? What software's on your phone?
Weather and lots of stuff.
Sorry?
Wireless.
Wireless, is that a program? What are you saying? Steve.
Steam.
That's not. Android and iOS and Windows 10.
See, up until the Agile approach, the syllabus used to just be these 4 because we're talking about traditional software. But in the last 4 or 5 years, there's been a total change in software development. Has anyone here written any software that you've made some money on? Do you know anyone that's written some software that they've made some money on? If you're going to try, you do? Yeah? What is it? What's the software?
Company changes. He's working in a company where they sell into different other companies for a time period. So he's working on the side. I don't know exactly stuff.
If I was going to say to you, let's make some money. Let's write some software. What platform are you going to throw it out on? Sorry? Phones. And what goes on your phones? What software goes on your phones? Apps, right. Apps are the real big thing. Because of apps, we've had to rewrite the syllabus because this Agile approach didn't exist a few years ago. But then people started saying, well, let's get these apps, let's get our apps out there. And then the whole idea is you've got to get your app out there before anyone else comes up with the same idea. Because no one's going to buy a second version of Flappy Bird. You already got Flappy or Angry Birds. Imagine if you had that idea of Angry Birds, you wanted to get rid of all your bugs before you released it, and then someone goes, wow, we've got Angry Birds out there. And at one stage, Angry Birds was probably the most played app. They even made a movie about it. Okay, you guys know yourself, as soon as something trends with an app, everyone else has to download it. Right? How would you get it? They download it, and like when Flappy Bird kicked off, everyone was playing it for that week or 2 weeks. Now, that's what drove this Agile approach. So this Agile approach is work in small teams, have the client involved, get it going, get it out there, doesn't matter if it's got problems, and we'll do bugs and fixes as we go along. Okay? But you want to get it out there quickly on the market so that you capture the market and someone else can't come along and steal your idea. Okay, here's just a little handout for rapid application. So there's nothing that there's not much to do on this. Once you've all got a copy, I'll ask for someone to read it out. Can we read? Thank you. Lawrence, that's a bit of the morning, right? The papers we can read it. Someone want to read this out loud? Jess?
No.
Please, give my voice. Did you say no?
Yeah.
Oh, okay. Are you embarrassed? Are you too shy to read it out?
I still not ready.
Lawrence, you want to read it out? Okay, Lucy, you'll read it.
The term rapid application development, RAD, is used very loosely to describe a software engineering process designed that leads to fast application development. It involves using an existing software package to develop a customized solution. Characteristics of rapid application development are lack of formal stages, coding languages used, relationship of programmer to end user, short time period, small scale projects and low budgets. One of the main features of the RAD approach to software development is the lack of formal stages. The development team often consists of only one programmer. Some of the applications used may be Microsoft Access or FilmMaker Pro.
FileMaker.
Oh, sorry.
That's right. Sorry.
Describe a situation in which a developer might decide to use the RAD approach to software development. Explain why the RAD approach should be used in this case in preference to the structured approach.
Okay, so just on that sheet of paper, you can write your answer. I want you just to describe a situation where you think RAD might be used. Okay, so I gave you an example, the attendance system, okay, that we use at the school. See if you can come up with a situation where you think RAD might be used. So they might be using a different product, they put a different interface on it, and a few constraints on it. So come up with a situation where it would be used, and then write down why would we use RAD rather than a more formal approach. If you don't know of an existing situation, use your brain to think of, make up one. Where do you think we could use something where the program's already written, like Microsoft Access or a database system or Excel? So we don't have to write the raw code for it. And we use, lots of workplaces use software. You see software being used almost every day, I'd say. You don't. Okay, if you have a look up on the screen, you've got a timetable up there. What do you think that might be written in? Why might you say that?
Got a good table format for buildings in it.
Right. Any other evidence? Does that look Excel-ish?
Yeah.
Does that? You're pretty spot on. Let me show you this. Student data. List all the students.
Yeah.
So what they've done, they've actually just taken Excel and then written their own little if statements and their relation statements, wrapped it up in their wrapper as eval, and sold it. A couple of grand a year. Not one off, a couple of thousand a year. And they didn't even write the code that runs Excel.
Is there any implications of that?
You're allowed to do it. That's what's called rapid application development. When you take the product that's already written, because they're actually writing this. So they're saying when you click on this, go to this. When you click on this, show this. Run an algorithm that does this.
What if assuming that uses Excel?
Yep.
And Excel isn't free. What if if you were a server software, would you have like to pay license?
I don't know. I don't know if they pay Excel a developer fee. I'm not too sure. You imagine they would, wouldn't you?
Yeah.
But there would. Yeah, I'm not too sure. I don't think you do. I think they're clear. I think it's part of the agreement. Because they're not modifying the Excel code. And they're not selling it as X. They're not saying here's a spreadsheet. They're saying here's a timetable. So that's a good example of rapid application. So that's eval program. Okay, so this is a candy. So that's it there in the face. When you open that up, it just looks like a new program. Still looks like their own program. For some reason, won't let me get in. you haven't got permissions to this machine. All right, but that's another program. So this uses Microsoft Access, which is Microsoft's database. So Nate, what have you got written? Nothing. It's going to take 15 minutes to do that. You got nothing written. Lawrence, you got it? What you read out what you've written?
I'm not sure if it's correct, sir.
That's okay. I didn't expect you to have it right. Just
No, I'm not sure if it really applies.
well, you've got it written down. So can you read it out?
Well, I was using an example of a game company using game engine and then making some,
Okay, so they're using a game engine that's already written by somebody else, are they? Okay, you're close. Yeah. Sydney?
I wrote a video game that uses the launch to start the game, releases a sequel game, the new launcher can use much of the old launcher's code.
But haven't they written that code anyway? Cole, you got something? No. Lucian?
I talked about Academy, like you suggested, how it was done originally using Microsoft Access, and instead of developing their own program, they just use Microsoft Access.
Okay.
Then to save money and time.
Jess, did you have anything written?
Yeah.
Yeah? What do you got?
The program needs to write a program that does similar functions to some program.
Right. What about when you go and buy something?
Also,
Where do you guys shop at? No one buys anything at all. No one buys skateboards or helmets or shorts, underpants. A big one, Lawrence. Where you go? What did you say?
Steam.
King's Cross.
Steam.
Steam. You seem to be obsessed with steam.
Let's shop on Steam.
You like hot and steamy, do you? What's steam?
What's Steam is if it's like...
What's their class?
If they play computer games, then they learn what Steam is.
it is basically.
No, I'm asking you to explain what steam is.
It's just like the PC gaming market.
Okay. All right. Does anybody ever go to a shop in the store? Right.
Yeah.
When you pay, what happens? To
To
who?
So they cash in.
And what? She just works it out in her head what she has to give you.
No.
What name? She uses a machine. It's called a point of sale machine. In the old days, they used to go ching, the drawer would come out like that. The things would pop up, $2, $10, whatever. These days, it's not like that. It's what is it? Sorry? It's software, isn't it? Yeah. Okay. Now that software that's been written for that Rebel or whatever it is, Diamond Ski, that software hasn't been written from scratch just for Rebel or just for Surf Diamond Ski. Okay? It would take some existing software, maybe Excel, because it's so it can do calculations, okay? Or maybe Access, or maybe both, and they would write software. Okay? Because it's not only calculates money, it's also got to make sure that there's some in stock, that when they carry out the transaction, it minuses one from stock, it keeps track of what's being sold, so they can say, okay, we've sold $200 worth of knee pads, or we've sold $500 worth of surfboards, or whatever. Okay, so it's got that software. But the people that have written it probably haven't written it from scratch. They've probably taken an existing program like Excel or Access, something along those lines, and then they've put their wrap around. Does that make sense? Okay. Can you think of anything else? Like petrol stations, they've got software. Because it's got to be able to manage the FPOS as well. Anything else that might use software that might not be written specifically just for that company? And I'm not saying all. Maybe companies like Maya, maybe they have actually gone to a software company and said, we want you to write software that controls our point of sale machines plus manages our inventory. They might have gone that, but there might be stuff out there in the market that say, hey, buy ours, we'll put your own brand on it, we'll put Myer on it, or we'll put Kmart on it, or KFC, whatever. And they might just be using an existing program. So you guys can't think of anything else where that might happen? Yeah?
You can already set up all of the things at shops where you like scan the stuff yourself.
Yeah.
Every single thing at shops needs to be exactly the same program.
But look, there's software all over the place. Like, when you just go to the footy, when you go in, you scan your ticket. That's controlled by software. Security systems probably controlled by software. All right, so the rapid application development, all it is taking some software that's already written and then just making modifications to it so it's got your own branding on it. So it's specific for the task. Okay. Now the big one that we have to have a look at is the structured approach. Now this goes, we won't talk about end user much throughout the next 2 years. However, there might be a question in the HSC might say, here's a example of this, here's something, blah, blah, blah. This is an example of A, structured, B, end user, C, rapid application, D, agile. Okay? So that's probably about the only question you might get asked on end user. Or it might say, Colin wrote a program for Mum, he used the end user approach, why did he use that approach? Why was that better off? Okay? And you say, end user is because it doesn't cost much, doesn't take a lot of time, it's not being marketed, so it can just be done. It doesn't have to go through all the formal stages. However, with the structured approach, they're going to ask you lots of questions. Okay? And here, there's going to be lots of marks on the structured approach. Besides pseudocode, the structured approach is probably what makes up the majority of marks. So, in your exam, you'll have a lot of pseudocode stuff where you're writing, reading, modifying, error testing. The next big component of marks comes from the structured approach. They'll ask you to name the stages. They'll say to you, this has happened. What stage would that happen in? They'll say, what stage comes after this? Why would they be doing this? Why would the structured approach be used? Define the structured approach. Seems like our manners are a little bit better today, which is pleasing. It's always nice to say thank you to someone and hand something out to you and give you something. You know, the old saying, manners cost you nothing, but it gets you a lot. Okay. Jess, I asked you before, did you have chewing gum? You said no, and then you just stuck me over here. That wasn't you in the assembly yesterday doing the chewing gum. Sorry? Gee, did you, mate? Lawrence, can you stop it, please? That's the second time I've asked. Okay, so the five stages of the structured approach. Now, you've got to commit these to memory. Okay, now this is the real boring stuff, but there's plenty of boring stuff in this course, okay? As much as there's hands-on, there's also boring stuff. You with us, Lawrence? I haven't got it written on the roof, mate. It's there in front of you. Okay, so the 5 stages are defining and understanding the problem, planning and designing the solution, implementing the solution, testing and evaluating the solution, and maintaining the solution. Now, it's actually a cycle, because if you're maintaining the solution, you're making sure it's still running, you're fixing up anything that's wrong. Well, if there's something wrong, how do you fix it up? Well, you have to define and understand what's wrong. So we go back to the beginning of the cycle again. So if there's something wrong, you've got to define and understand what's wrong. Then you have to plan and design how to fix that thing up. Then you implement it, you test it, you evaluate it, and then you maintain your solution again. And again, if there's something else that's wrong, then you've got to go back and... So you understand how it's a cycle? Just like when there's bugs and when things break down and there's improvements to be made. Before you can make those improvements, you've got to understand what it is that's wrong. Why do you need to make the improvement? What is it that's not working? Okay, so I've given you there the characteristics of the structured approach, including distinct formal stages. We've just talked about the 5 stages. It's a long time period because it's thorough. It's for large-scale products. You don't want to put a lot of time and effort into it, and I've been there, believe me. I spent 2 years on the reporting program that I then couldn't market, so I didn't get up and running, so I actually lost all that time that I put into it. So you don't want to take the structured approach and put a lot of time and effort into it if you're not going to get the money back. Okay, so if it's on a little solution, if it's on a little problem, you don't take the structured approach. If Mum says to you, can you just write something up for me that, works out, it calculates my fuel consumption. Okay, Mum, well, let's sit down, we'll have an interview. All right, then I'm going to talk to Dad as well. I'm going to research on all the same models that you've got. I'm then going to start drawing a data flow diagram. I'm going to do a data dictionary. I'm going to do a context diagram. You wouldn't be doing that, would you? You'd sit down, you have a go at it in about 10 minutes, and then you'd say, yeah. But it's going to take you. You don't want to be working on it for 3 or 4 weeks if you're not going to get the return on it. So the structured approach is only used for big, large-scale projects. So it's used for companies when someone comes to them and goes, we'd like you to write us some software that does this. Okay? Then they start taking that approach. Large budget, because as I said, time is money. Involvement of a development team which consists of system analysts, designers, programmers, and the clients, of course. And it's not just the boss. You've got to talk to the managers and the users. You've got to talk to the whole corporation. Okay, so I've broken down the stages for you, and I've made some points under each one. Have a little read through yourself first, and then I'll talk to it in a few minutes. But just to give my voice a break, and also give your ears a break. Now, when we come across things that you haven't seen before, don't freak out because I'm going to explain them. Okay, so we're going to spend a bit of time over the next few weeks going through the structured approach, and we're going to explain the things that are on the sheet. At the end of the lesson, please put the sheet into your folder. I swear there's some of you that still haven't bought a folder yet. If you have trouble getting to the shops, give me $2, I'll go and buy you one. I'm going to ask you to give me a brief explanation of each stage. So make sure you're actually reading it, not just pretending to read it. You really need to understand this stuff, okay, guys, because as I said, it'll be your exam, okay, it'll be your prelim exam, and it definitely will be your HSC exam. If you don't get this bit, all you're doing is giving the other kids in the state an advantage over you. They might ask you to explain one of the stages. They might simply say, oh, Louis used the data dictionary. What part of the structured approach? What part of the cycle? What stage was that at? They might say, do you explain the testing and evaluating stage? Question is, what approach should they take? Another one is, Nathan did this, blah, 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 blah. What approach did he take? Lucian has to do this. What approach should he take? Justify your answers. And when you justify, you have to give reasons for it. Chose the structured approach because it was a large-scale
project. He needed formal stages. He had a large team working for him. Needed to be thorough. The company didn't want any bugs when it first went out because they were worried about the professional look of it. Feel free to highlight anything in that on the sheets. They're yours. Better heads on people. Just like the door. You probably want the handouts then, mate, do you? Or, oh, okay. You hung over from diversity, were you?
Yeah.
Big day, isn't it? You guys came last year, didn't you, from your junior campus? What did you think of yesterday? Do you think it was better than last year's or worse or about the same? You weren't here last year?
It was
Sorry?
it was
I
think last year was better.
Yeah? Why is that, mate? More activities or more atmosphere?
I think it was more funny.
Yeah. Oh, okay, so it was more like a day away.
Yeah.
What do you think of the assemblies in the morning? The year 10s had to go into an assembly first, then they did a tour of the school, then they went back into that assembly. What do you think of the young talent first? Oh, did you want to keep by it? So, Eli, this stuff I've handed out is pretty important, mate. It's going to be in your prelim exam. It'll be in the HSC exam as well. So we're looking at 5 approaches that are used for software design. 5 approaches to solving. We call it solving because when you come up with a program, it's actually called a solution. Because it's solving a problem, as in the problem there's a need for it. So the 5 approaches we use are the end user, the RAD, which stands for Rapid Application Development. I think I just gave you a hand out that. Prototyping, which we'll go a bit more into later on. Structured approach is what I've just given you as well. And the Agile approach, we'll talk a little bit more about that. That's a new one that's been out in the last few years, and it's mainly because of apps. Apps is mainly to kick this in. Agile approach, it's quick, small teams, and they're very flexible, and they change stuff as they go along. Say with this structured approach, we get asked questions like explain one of the stages, or they might just say what are the 5 stages, or they might say here's some stuff happening, what stage is that in? What's a sequence? What's a sequence? Yes? Sequence. So in programming, a sequence is just where one process follows another. In a flow chart, it simply looks like this. This thing happens, then that thing happens. That's a sequence. What's a selection, Lawrence? A selection, like people, they always ask the question back to me because they think, oh, I don't know, they'll give me a couple of seconds to think about it. I think psychologists also say that it shows the sign of nervousness or a sign of dishonesty when you repeat the question back. So what's a selection? It's just. Yeah.
You've got multiple options and you can see.
Selection is just where you have a decision. It selects either this or this. That's actually a binary selection because it's either this or this. That's just a selection. If it's true, do this. If it's not, don't do anything. That's just a selection. That's a binary selection. If it's true, do one thing, else do another. What's iteration, Nathan? Iteration. You don't have to look on the sheet. You don't know what iteration means? If I say to you, let me reiterate, what does that mean? Let me say, sorry? Repeat. Let me say it again. When someone reiterates, they're saying something again to stress it. You know, in comedy, a lot of those comedy, they say something, they say it twice, they go, do I, mate? Do I? That's what's the fun, a lot of American comedies do that. So when you reiterate, you're saying it again. So iteration is where we, what did you say? Repeat. So iteration, but it's not just repeat, it can also be
Loop.
yeah, what type of loop?
Repeat.
Could be a for loop, a repeat, or a while. Okay. What I'd like you to do, if you finish reading that, I'd like you to take a pencil and just make a dot next to any term on that paper that you're not too sure about. So anything that's on that paper that needs explanation. And if you don't dot it, and I ask you what it means, and you go, oh, I don't know, I'm going to kick you up the bum. It's a bit like when I go, is everyone okay with that? Does everyone understand? Does anyone not understand? And not one person puts their hand up and I go, okay, can you tell me the answer? And they go, no, I don't understand. So I want you just to put a pencil or a red dot just next to any term on those, in that structured approach that you don't understand. Do you know what an IPO diagram is? If you don't, put a dot next to it. Do you know what a subroutine is or a module? If you don't, put a dot next to it. Do you know what desk checking is? Everybody should have a dot next to EBNF and railroad diagrams because we haven't done that yet, unless you've done that on your own time. A runtime error, a stub, traces, breakpoints, line stepping, flags, debugging out mistakes. anything else besides maybe? No, we've worked well before. Is there anybody that doesn't know what an IPO diagram is? We have done it. Yep, but input, processing, output.
Oh, right.
Okay, so we write down here what our inputs are, so we could say hours, rate, processing is hours times rate, and the output is the pay. So we simple like that. That's the output program, diagram. What do I mean by data types? What do I mean by data types, Eli? You sure?
No.
Okay. Matthew, what do I mean by data types?
Different types of data.
Oh, good one. Take the second word. Can you give me an example?
No.
No, okay. Colin?
String.
Yeah, string. So with data types, so when you're planning your solution, you've got to stop and think about what types of data you're going to use. When you're going to throw your inputs in, how are you going to store them? You're going to put them in string variables or integer variables or characters, booleans, arrays of records, which we haven't looked at yet. Records. What happens if you try to put knuckle you want to do that? Well, there's a third time now. Persistent disobedience. What happens if you try to put a string into an integer?
It crashes.
Either the program might crash, might not work. So there's some kind of problem, isn't there? Okay, we get a type mismatch. You're going to cause yourself problems. So you need to stop when you're designing your solution. You need to stop and think about what type of variables you're going to need. Okay, and what the type are, and you might even need to think about what size that they're going to be. That's a common problem a lot of you guys still have. You know, you've got things that are called bytes, or you've got somebody who are trying to put strings into integers. You make an array of integers, and then you're putting cat, dog, cow into your integers. Okay, you don't have much room to find. So you need to stop and think about that. When we, one of the tools that we use in the course is called a data dictionary. Okay? And we'll go over this again. I'll just give you a bit of a tap into it now, because it's always a question about data dictionary. It's always what could he use here. So data dictionary. I might say, why did he use a data dictionary? How is a data dictionary useful? A data dictionary is simply a table and you're right, mate. Simply a table that lists all your variables that you're using. You list what type they are, and you might give a description about each one or where it's used, and you might say how big it is. But how big it is not too important just in programming. If you're going to be doing databases, where you're going to have lots and lots of records, then you probably want to say how big each field is, so that you know how much it's going to take up. But with a program, we have a data dictionary so that you know what variable is doing what. So you can look at your data dictionary and go, oh, okay, it's this variable here that's holding the time that they submitted it. So then you can find that variable in your program and go, oh, okay, this is the one I've got to change here, or I've got a manipulator, or I've got to use it here. Okay? You don't want to end up using two different variables doing the same thing. You set it up here, but down here you call it a different name. Oh, show this. You're getting 0 out each time because it made up here it's called A. You said let A equal 10, and down here you're saying show B. Where you should be saying show A. So a data dictionary is just simply a reference table of all the variables you've used, what type they are, okay, and what you're using them for. If you use meaningful variable names, intrinsic documentation, you don't really have to put what you're using it for. It should be self-explanatory. If you're using a variable to hold somebody's age, you would call a variable
Age.
age, right. If you're using a variable to say how much money they were paid out,
Pay.
pay, or maybe total pay. Okay, because you might have paid for each day, but then the whole lot might be called total pay. So you be really literal. I know you're lazy when you start, I know you're all lazy, but I know when you start coding, you can't be bothered writing out a 20-letter name for a variable. You'd rather just go A, B, C. The only thing is, it gets messy. Alright? So your code has to be easily maintained by you and by somebody else. If you guys go and get jobs after school in software design, you'll work in a team. Okay, you'll work with other people. Before your code gets produced or sent out, someone else will look at it. If they can't understand it, if they can't read it because you haven't formatted it, you haven't got meaningful variable names, they're not going to help you. Okay, the boss is going to say, mate, you expected Nathan to read your stuff and give you a hand, give you an opinion. You can't make heads or tails of it. Alright, so you need to have meaningful variable names. Louis, you got any dots on yours? Yeah? You want to tell me one?
Well, the ED in it.
Okay, good. Yeah. That's the one I said I should have. Any other dots?
Floating point is real.
Okay. Eli, you got any dots on yours?
EBNF.
Besides that one?
Records.
Okay, cool, good. Lithium, any dots? Besides EBNF?
Railroad diagrams.
Okay, all right. Good. They're fun to work with, railroad diagrams, be able to train, track and get the flow of trains.
And not entirely sure what a subroutine is.
Okay, all right, good. All right, you'll catch on to that easy. Colin, you got any? Any dots besides EBNF?
Line stepping.
Line stepping? Okay, that's where I take you guys out to the West Country and Western Bar. We do a bit of dancing, line stepping. Yeah, you'll be right, you'll pick up. There's lots of cowboys there, mate. No, line stepping's got nothing to do. There was a big trend back in the 90s called line dancing. It was huge in country and western music. They probably still do it there. The women love it. They all stick together. They do this tunes. Because the Americans love it because it's so cool. Why don't we have cheerleaders here like they do over there? Unbelievable. But they do that like in the high school. We've got cheerleaders in high school, college. When I was in Vegas, catching a bus down the street, a few hundred uni students got on. They were going to a football game. They didn't even live in that state. They came from another state to go and watch the college play footy. Just when we played footy for college, there was no one, not one person on the sideline watching us. Over there, they got thousands of people that go to a college game. The college games are also on TV. Things are different in the States. Any other, Matt, you got a dot on something?
Flags.
Yep. You know, when you go to the beach, where should you swim at the beach?
Between the flags.
Between the flags, right? Well, that's got nothing to do with that, mate. Any other dots, Lawrence?
I've got railroad diagram.
Okay. Sydney?
One-dimensional array.
Sorry?
One-dimensional array.
One-dimensional array. Okay. Has anybody else got a dot on that? A one-dimensional array? You have? Okay. Well, we have already done one-dimensional arrays. We did arrays for about 2 weeks. They are one dimension. We will look at two-dimensional arrays and other dimensional arrays, 3, 4, whatever. But what you guys have done so far on your arrays, they are one-dimensional arrays. Okay? Lucian actually got onto 2D arrays the other day. So when we just have a list of values, we just go like 1, 2, 3, 4, 5, 6, 7, whatever, 1.4, 1.10, that's a one-dimensional array. So you guys have already done that. Okay, so yes, you do know what one-dimensional arrays are. Okay, any questions before I let you go? Please don't lose these, okay? These are valuable to you. Please, if you go home and Mum goes, "Where's your homework for software design?" you go, "No, he's cool. He doesn't give us that much because he's only got a lot of other stuff to do." However, he has given this to us for us to read over, because when I go to do my HSC, there'll be a stack of kids in New South Wales who have no idea what construction approach is. I will get more marks than them because I already know, because I'm looking at it once a week or once a fortnight. Even if you looked at this once a month, which is not much, you would still be ahead of other kids in the state. Okay? Once again, nearly everything I say to you in this class, you can write it down and you can use it. Unless we're talking about something that's silly like cheerleaders, anything else, if we're talking about something in software, write it down. Okay? Right, see you later. Have a good weekend. Be safe. The company's safe. Don't set yourselves on fire like that. You couldn't get up this morning, mate?
I just had a headache.
Me too. I was up at 5. All right, see ya. Jess, have you got a folder? Yeah, cool. Nathan, you got a folder?
See you, sir.
Put that in the folder. I want you to bring them each lesson, because I'm going to start breaking down stuff that's